Okay, it's already 4:30, so I think we can start our session. I hope I am audible. Good evening to everybody. Welcome back to our week 2 doubt clearing session on fundamentals of additive manufacturing. I am Ananya, and if you have any query related to the lectures of week 2, then you can post it in the comment box, or you can raise your hand. I'll ask one by one. And yeah, if you don't have any query, then I'll just go through the topics quickly and we'll discuss the previous year assignment of week 1. No one is having any no query? Have you guys watched the videos? I want to understand the concept of aspect. Okay. Anything else? So I think I'll wait for 2-3 minutes more and then I'll start because still people are joining. So let everybody join first and then we'll start. And by that time, you can post your queries in the comment box. Would like to know about problems related to support structure generation, week assignment, yes, and compulsory for 3D printing. Okay, so few lines of triangle from SKY code. Outer loop this. If the triangle rotates in 90-degree clockwise about x-axis, then 90-degree clockwise about y-axis. What will be the unique corresponding vector to the new order? Okay, and so maybe one by one we'll try to solve these things. Uh, Starting with the smallest one, which is STL file compulsory for 3D printing? The answer is yes. STL file is compulsory. The thing is, if we are not providing the STL file information to the 3D printer, it will not be able to print the whole part, because in STL what you are basically doing is you are dividing the whole part into, or whole part surface into small triangles. And in 3D printer, we are not really providing the CAD model with smooth surface. We are providing the STL file information, because that is readable to computer. Computer cannot read our English sentences, but it can read the binary code, the 0 1 codes, or for 3D printer it can read the ASCII format. So for that, STL file is important. To define a smooth curve, we will select more number of triangles, and for general surfaces like flat surfaces, we can go with smaller triangles also. It basically depends how much accuracy you need. Would like to know about problems related to support structure generation in week 2. Okay, it's in week 2. I want to understand the concept of ASCII and that y-axis rotation thing. Okay, maybe we will do first this ASCII one. And for ASCII, uh, so STL file is like in for 3D printing, we make the CAD file, which is nothing but the 3D modeling or 3D model. Now, if I have made the 3D model, then I can print that same model in the 3D printer. But how can I send that 3D model to the 3D printer so that language will be understandable to that printer? So that understandable language is STL file. Okay, which is standard tessellation language and standard triangle language, where a full surface is classified or divided into small triangles, so that the whole surface of the 3D model can be defined using these small triangles only. But again, sometimes it's not necessary. Translation annotation. Okay, so now how the STL file is getting read by the computer of the 3D printer, because HCl file again is a geometry. Triangles are geometry. These triangles are basically geometry. How can a computer read the geometry? A computer doesn't have any eye, so it reads the coordinates of the geometry. Now you have already divided the whole surface into triangles. So obviously now triangles do have three vertices or and three lines. So basically 3 points making three lines. So this three vertices will be basically the coordinates of a particular triangle. Now computer will read the coordinate. Now again there will be millions of triangles. How can the computer read those millions of triangles in such a way that it can make the whole surface at the end of reading all those coordinates? So by that reading technique, they have their own technique, but how can we provide that information to computer? One thing is you just make the CAD file. This is one technique. You made the CAD file, save it in STL, and you just put this in the 3D printer and it will be done. If you do not have any CAD software, then you have to make the STL file. How we can make the STL file? Obviously by writing the code. Now by writing the code means there can be two types of codes. One is the regular code, like some loop, some starting of a loop, then the whole loop, then end of a loop, and this loop will be continued for million times or just 10,000 times, 20,000 times to cover all the triangles present over the surface, so that we can define a whole geometry into few triangles. Now how can I write this code? This code writing thing is called this ASCII, and computer also understands the binary code. So obviously there is another way which is called binary. So binary code is a bit difficult. We really cannot write it so easily. So we'll not go into that binary thing, but ASCII is more user friendly because code writing is more user friendly. So from that point of view, we can make the ASCII and provide it to the computer. So this is why ASCII is important. Now how ASCII is getting generated? There is one format I have written somewhere. Yes. So for ASCII again, we will provide the information of triangle. For triangle, three vertices and three lines are there. So three vertices coordinate will be enough to make the triangle. But again, we are talking about something 3D. So that will be vector, not a scalar quantity. For vector, there will be a direction. So if I want to say the triangle will have a direction, that means that triangle will have a normal, and that normal can be outwards facing or backward facing if the triangle looks like this. So if this is 1, 2, 3, then using right hand thumb rule, we can say that this normal will go in the front. This arrow is the normal. So normal vector we generally write like this. Now when talking about ASCII format, so first we define the facet normal. So these triangles are also called the facets. So first we define the name of the triangle. Suspicious. Mm, Then after the name, we'll start our loop. Maybe next page. Name of the triangle. Then starting of the loop. Starting of the loop will start like facet normal. We are putting the value of facet normal. So obviously nx, ny and nz means that normal will also have a direction. So from a direction it will also have some coordinate, like from the middle of the triangle the normal will go. So this will be the coordinate of the normal, and this normal always be the outward normal, means the right hand thumb rule. Then after facet normal we'll start the outer loop. Like facet normal is this. Now we'll make the outer thing. So for the outer thing, we will call it as vertex. Obviously we are defining the points. So point 1 ka x, the y and the z coordinate of 1. Then we'll call the vertex of 2, point 2, and then we'll call the vertex coordinate of point 3, and we'll write it in such a way that this 1, 2, 3 should be in counterclockwise direction. So if we are making uh, a triangle like this, 1, 2, 3, you just write it in this way, like 2, 3, 1 or 1, 2, 3, just not like in this way. Okay. Then when the coordinate definition of or defining the coordinates is done, you end the loop and end the facet, because a facet is having coordinates of vertices and a normal coordinate, and all the things are defined. So this will make one triangle, and in this manner you can make all other triangles, and then you just run the code. Your object will be made, as professor has also showed in the class, that if this is the most simplest geometry, and if you want to make this, you can just define two triangle of each side and can make the ASCII code, and it will run and will give the triangle and the whole object to us. So whoever has joined later, for them, if you have a query from week 1 or week 2 or whatever, you can post your doubt in the comment section and I'll try to solve them one by one. Now, I think ASCII thing is done. I want to understand the concept. I think it is done. Or if you have any other query related to the concept of ASCII, you can just turn on your mic and ask me out also.
Yes, ma'am, got it. Thank you so much.
Okay, okay. Next is the okay. So now as the ASCII code has been formed, now if you want to rotate it again, there is a long calculation of the rotation. So maybe if I can fit all the things in this screen. So for rotation, you have a point. Suppose this is your coordinate, obviously x, y, z. Everyone, please try to join within 4:30 because otherwise it gets difficult for me to make you join all every time in between the session. Okay. This is a point, and from this point, this is a point of a triangle, this thing, and you want to rotate the triangle by 90 degree. So if you want to rotate the triangle by 90 degree, means this triangle will be like this after some times. This is 1 and this is 2. And if you want to translate the triangle by some value, like here the triangle is first position and you want to make it here, so there is a difference between these two. So if you want to rotate it, like if you want to rotate this point by some angle, so if this is alpha, this will be beta. So you have made this beta minus alpha rotation of a point. This is degree. And other situation is you want to translate this by x x value. If you want to translate the triangle, the normal of the triangle will not change, but if you want to rotate the triangle, the normal of the triangle will be changed. So there is difference. So to translate the triangle, you can make the simple algorithm. I mean, what should I say? Just some not simple plus minus, but some vector addition subtraction with the previous data. But if you want to rotate it, you have to calculate all the theta values again, because what is the most important parameter of a vector is the direction. And here the triangle is having direction as the normal. The normal is having the direction, the triangle is not having the direction. So the triangle's direction means the normal's direction, n. And this n value, how it will be rotated, this is different. So to understand this problem, maybe I'll take the problem that professor has shown. So if this is y axis, this is z axis, and this is x axis, then maybe I shouldn't write all the things because you guys are already having the notes, I think. Do you have the PDF note with all of you? some of you can just turn on your mic and say. I don't know. Those are uh, accessible to you or not. Can anybody tell me? The class notes, you can access that or not?
Yeah, yeah, we do have more.
Okay, you have the access. So you have the things there. So it's basically if you want to rotate it with this beta amount, now this angle is beta. So now this Z2 value will this Z2 value will be L sine beta plus alpha, because obviously this length was L and this was alpha. Now this is beta. Yeah. And if you want to change the y position, then again y will be again some value with L. And if I want to just discard the idea of taking L, because I don't have the coordinate really, and I do have the vertices coordinates of the triangle, so I'll rather write like y1 cos theta or beta, or just theta minus z1 sine theta. So from that we'll have a what is it called, matrix. And from the matrix you can calculate the value, like for the kth vertex, or for ith vertices, what will be the new position of it, and what will be the normal value or normal coordinate of this, because this is whole math. So should I do it for you, or what is your doubt exactly? I just put the value of 90-degree at that position. uh, your Vishnu, you have asked me your doubt that 90-degree clockwise.
Madam, I'm Prasida. What I understand is that
Yes.
the question which is asked by Vishnu, when we try to solve that, we are getting an answer, and that answer is not there in the option. I feel that is the problem. Maybe Vishnu can answer.
Okay. Okay, that is the problem. Okay, there is a question. Question where some
This
quiz.
question is from
Assignment,
assignment.
assignment.
In assignment 2, this is the second question. And when we try to solve it, we are that answer is not there in the option. Means when I did, it was the problem.
Okay, I have
Maybe
seen the assignments because I haven't checked it whether the same value is coming or not. I just have trusted the whole process, and it seemed that the process was right. So I have also not checked whether it's correct or not. Okay, then I have to do the maths again and see what are the values coming, right? That would be
yeah,
the
madam. Maybe
yeah.
maybe you can do it and check
Okay,
whether the
again.
option is correct. I don't know whether I did a mistake, but I
No,
don't know
if
whether it's
many
the
of
same
you
with
is having the same error, then it may happen that there was some problem in the calculation. It may happen, not a big deal. Okay, so I'll do the maths. So it will take me some time. In the meantime, if there is any other query relate other than doing the maths.
this is another doubt, madam. This from the professor's class. This support structure related to
Yes.
there are two methods of support structure generation,
Yes.
right?
Yes.
And in the support structure generation from contours.
Yeah.
Two methods are containment method and optimal method. I understood the concept, but I am not able to solve the problems related to that. That is question number 13 and 14. If you can just give gist of that, I think we can solve it.
Okay, I haven't seen that question. What was the question? Can you tell me? 13 and 14? Maybe we
1 minute.
can.
That
Yeah.
is a problem with figure. So
With figure.
the
Okay.
object shown in the figure has to be fabricated with AM process with a thickness of 10 mm using containment method.
Okay.
Means if you have a figure with dimension, using containment method, find out the volume of the support material, like that. That is the essence of the question, and there is a figure is also there.
Okay. Okay.
If a similar question means if it can be solved by you, I think we can understand the concept how to do.
Okay, now then again, that is again something related to I have to do solve all the problems. So that
Yes,
will take
yes.
again a lot of
And
time.
also question number 14 is also a similar question that is related to optimal method. Two methods are there,
Hmm.
containment method and optimal method. So based on, we understood the concept from SIR's class.
Yeah.
Means I am telling about me. I
Yeah,
don't
yeah, yeah.
know about, means them, others might have solved it. I
Yeah.
am concerned about the support structure generation by containment method and optimal method. Problems related to that. Don't know
Okay,
how to
problems.
solve.
Okay,
Mm.
okay. Then, okay. For this, I have to see the figure and I have to see the assignment. So, okay, that can be done in the next part of this class, like after 1 hour maybe. So before 1 hour, uh, 30 minutes is left. So if you have any other doubts which can be just like briefly discussed, that I'll do. Then I'll shift to the solve things. Okay, because I have to see the assignment then, that 13, 14. Any, okay, there was another doubt also. Okay, I'll go through all the topics one by one in just 10-20 minutes. Then we'll try to solve the problems. So in week two, the lectures were mainly focused on the STL file modification and the support generation. So for the modification, as I have told you that if it's rotating by some theta or beta angle or it is getting translated. For rotation, the normal will be same, and for translation, sorry, for rotation, the normal will be changed, and for translation, the normal will be same. So then the problems we will solve it. After that, we have seen the support generation techniques. So in support generation, in contour method, so we can just make the projections of the part which is requiring the support. Like for every material you can remember this thing. Yes,
Excuse me, ma'am.
yes.
Yeah, may I know what is the meaning of contour exactly?
Contour,
I
okay.
mean,
Yeah, yeah, sure.
yeah.
So if this is the part, okay, this is the 3D part I tried to make. This 3D part is having one portion up to this point. This portion looks like this, a simple cylinder, not cylinder, a rectangular pillar. Okay, and this portion, like up to this portion is looking like again a rectangular cube, but it is having more width than this one. So the contour means basically if you want to see the projection of a particular part in the ground, that will cover the periphery of that whole object. So for this portion, the contour will be like this, and for this portion, the contour will be like this. So in overall, if you are putting some light, okay, this is a bulb, and if putting some light on this product, so there will be shadow of this product, and you cannot see this part in the shadow because this is smaller part and this is bigger part. So you will see a shadow like this. Understood? And this shadow is basically the contour of this whole product.
Okay, okay.
So we basically
Got it.
say that the periphery, that is the contour. Okay. So if
Yes, yes.
we are having the bone structure has been shown. So if we are having this bone structure like this, and if I want to see the contour of this bone structure, So basically I'll divide it into layers. And for example, if this is the first layer, this is second, and this is nth layer. For the first layer, the part somehow looks like this, and the contour in the, this is top view, okay, top view, the contour will look like this. For the second layer, again the contour will look like this. For the, this is suppose 10th layer. For 10th layer, it will look like this. For the nth layer, it will somehow look like this. If we are just cutting the bone into thin slices, and now you just try to imagine the periphery of that slice, that is the contour. So in contour method, uh, we can have the whole contour thing as a support. We can have an optimal dimension of the contour, so that the part which doesn't require any support, that portion can be the, or the support which is unnecessary, we can just discard those portion of the support, because support is again the waste of material. So we are just trying to optimize the use of material or the proper usage at the time of 3D printing. So in contour method, we will take all the contour into account, and then we will try to make the bigger periphery of all contour. Like if the contours are like this, these are the contours, we will take the outermost periphery of all contour and just like a summation of all the contours, and my support structure will look like this for the whole part. Even when for this part no support is required, I will put the support in this all over portion, just because I am taking the whole contour, the summation of all the contours. Here the wastage is more, so that's why we go for optimal method. In optimal method, we just try to find out that which portion is really needed and which portion is not needed. If we are having one contour, now I was talking about the thin slices of that bone. So if for layer 1 I am having this slice, and for layer 2 I am having this slice, and if this both the slides are coinciding with each other like this, then I'll have the summation of the contour, and this will be the summation. In first method, I'll take this whole periphery. For the second method, I'll see whether for the second layer, because this is layer 2, for layer 2 this portion is not needed. Here we do not require any contour, any support. So I'll just discard this layer for layer 2. For layer 1, I'll make the support like this, layer 1 support, and for layer 2 I'll make the support like this. For layer 3 I'll see what type of support is needed. So this is the concept of, or kind of the overall concept of,
Yes, ma'am, got it.
yeah. And then comes the next portion, which is some terminology related to the support. Okay, I have done it wrong. For this part, however, it's looking like this portion is empty, but this is connected to the base like this. So obviously for this part, no support is required because there is no overhang portion. But for this part, support is required. Again, if I zoom it and see if the support will be in this portion, then for this portion up until here, the support is free. Like The support is really not connected to the side surface of the part, but this portion is connected to the part, connected to the object. If it's connected to the object, and then two things come. One thing is, if you make high density support, density is very high, high density support, then you will provide a rigid support to the part, but again the removal will not be good, because for rigid support, if you want to break it or if you want to deattach it with using some hammer or spatula, you can destroy the accuracy of the real object. But again, if you are not making high density support, like low density support, some supports like tree support or something like that, then you will hamper the rigidity of the support, because the main working of the support is to give enough strength to the object, to the overhang portion of the object. So again, for tree like support, maybe it will not be enough for the part, but again, tree type of supports are easy to remove. So not rigid, rigid, not easy to remove, but not rigid, but easy to remove. So we have to optimize the support parameter for this portion. But for this portion, we can make a support in such a way that the rigidity will be maintained, because removal will not be that issue, because the surface, side surface of the body is not really attached to it. Only this portion is attached to the body. So this is understanding about support. So this support is called stale support and this support is called fresh support, because this fresh support is something which is directly attached to the part or object body, and stale support is at something which is attached to the fresh support. Then after this part of phrase support and still support, the next part comes, which is the orientation of support. Now, orientation of support mainly depends upon two things, like not two things but many things, but the most important thing is your time of the printing should be optimized. Optimized means minimum in case of time. The cost of the printing should be optimized, again minimum. So for this to be minimum, we have to see that how can we rotate the structure in such a way that the support structure, the lesser number of support structure is needed, because again otherwise support will take some time to get printed. For that we had a formula. Okay. uh, in this formula there was an assumption. First assumption is that no cost is added here to make the real part and the CAD model. Okay, so the cost and time, which is also related to the cost of making the support in 3D model, is not taken here. So the total cost is equal to the pre-processing cost plus the machine related building cost plus the material cost and the post processing cost. Again, the pre-processing include the support, like the time of support, then the maintenance of the machine, the staff uh, cost, the computational cost, the building cost, everything. Now the building, for C building, it's just the time of building and the machine running cost. The material cost is simple. You just taking the material from the 3D printer as the object material, or you can put some material as a support, alag se, so that you can easily remove the support, or you can take the same material as the object and make it less density support so that it will be easy to remove for you. So material cost, like the modeling cost and the support cost. Again, the post treatment, like after removing the support or to remove the support, we sometimes use some tools. So the cost of the tools after removing the support for um, metal parts, we go with some grinding or milling, and for polymer parts, we go something like buffing operation using sand, some short blasting operation. So those type of things are used for polymer. And again, for resin, like for SLA, we go for UV curing and then buffing, so and also water cleaning and alcohol cleaning. So those are some post processing costs. And by adding all this um, cost related to other techniques, will give us the total cost, which we have to minimize somehow. So to minimize the cost, you just orient the so first thing should be orientation of the part in such a way that no support is required. Because again, if you think that is this, I'll make like this, then no support is needed. But if you make like this, then there is two problem. One is, we already know that the cost related to support, and cost means the time related to support. Other thing is, when you'll remove the support, now this surface will not be good as this surface, which is building without support. So where, from whatever portion you will remove the support structure, that surface gets washed like the other surfaces of the printed part. So that's why also we sometimes just try to avoid putting any support structures. But if I ask you one question, that is, what is the need of support? Because we are talking about support structure in the whole week 2 lectures, but do we really know that what is the exact need of support structure? And do we have any technique which, using which we can avoid building the support structure? Anyone? Anyone? I think some answers are known. You can type your answer in the comment box also. My question is whether all additive manufacturing needs support structure. Like, what is the need of support structure?
Ma'am, to prevent the collapsing of material, sagging and the collapsing of the material.
Why a material will get collapsed during printing or after printing?
Because it's heated and it's in this semi-solid form. So,
Okay, so if you are making a part like this, a simple cube, and over a cube there is one cone. This is your base. So how this part will get collapsed?
Well, this part doesn't need any support structure. parts where there are overhanging features,
Hmm.
there we need support.
Okay, so if I tell you that a part which is having overhanging portion like this needs support structure, right? Whatever you are telling.
Yes, yes,
Yeah. So
yes.
it is also correct. So this is one need of support structure. What is the other need of support structure? Like, okay, so let me reframe my question. So here we are putting support because there is nothing. This is air, right? In FDM process, this is air. So that's why we are putting support in here below this, so that as a pillar, like the supports will act as a pillar and hold the part during printing, right?
Correct.
So, okay, some answers are there: ensuring print stability. In LPBF, support structures are not required. Angle between facet normal and build direction. Okay. In SLS, plastic, no support required because material density is low. Okay. So, yeah. Now, for this scenario, like where there is air, the support is needed. So, as like one person said, LPBF doesn't need support or SLS doesn't need support. So, in LPBF, if we are interested to make this part, so what will be your answer? Is support needed or not? Two person has said that no, not needed. I want to know other answers also and with justification.
Ma'am, if you can change the orientation of this proposed diagram that you have shown
Yeah.
here,
So for this,
then you don't need support.
yeah, absolutely correct. But if there is some portion, like here also there are bulbs like structures. Anyway, we need
Ah,
support to print this structure. So at that time, I am asking. You are absolutely right. This part can be oriented in such a manner that support is not needed. But if it cannot be, then
then you better know. I don't know.
no, not that thing. I just want to know your understanding about support, because we are trying to solve
Yeah, yeah.
problems in support structure. We are trying to make support structures. But what is the need of support structure? One thing is overhang. Absolutely correct. Then what about the process in which there are powders below overhanging portions?
Powders will act as support.
Okay. Any other answer? One question I am having. Uh, you are having, what should I say? Maybe resin, okay? Or just water. This is water. And you are using a burner or just a candle, mombatti, okay? You are using this candle to evaporate the water which is present inside the container. Now you assume that this water is a rigid body. Rigid water means if I want to evaporate the water, so all the water inside present inside this, maybe up till this level, the water will be evaporated. And after it is evaporated, the new water level will start from here, because this level will come down, right? This is the normal common sense. But let's assume the water is a rigid body. Okay, so rigid body means it will not move from its original position, even the lower portion of the water is evaporated. So if this portion is evaporated, this portion will become empty, but not the water which is present in the upper body will come. So this is the assumption. Is it clear to all of you? I think yes. If your answer is yes, sometimes you just raise your hand. Yes, okay. So now, if you are heating the pot in this portion, so what will happen? The water which is present inside this portion will get evaporated, right? The water present in other portions are still there. You are moving the mombatti or the candle in upward direction now. So all the water present in this direction will get evaporated. Now you want to evaporate the water which is present in this portion. This portion. Okay. How can you evaporate the water present in this portion? How? If you are not evaporating the water which is present in below that portion. So this is region A. How can you evaporate the water present in A, and this is portion B, when you are not touching the B portion?
We can heat from the top.
Okay, the candle is like you. How can you heat a pot of water from up using a candle? You have to heat it from the down below portion. No? By chance, if this call ends because there is the time limit in GPay, I wanted to resolve it but I couldn't. You just join this meeting link again. Welcome back. Sorry for the interruption. So basically, my previous link got disconnected and I couldn't join it through my Gmeet again. So I have created a new link, and as I couldn't reach all of you out through with the new link, so here I'm just trying to tell you the next topic here. So and we'll upload it in YouTube so that everybody can see it and understand the topic what I was discussing previously. So as I was discussing, so if I want to evaporate a water which is present inside the body, I cannot reach it until I can evaporate the water which is present in the B region. And that's what happened in case of powder bed fusion like additive manufacturing processes. So yeah, some of you are telling that LPBF doesn't need any support structure as the powder particles will be present in below the part. But again, there is a difference between the solid body and the powder particles. So basically what happens in LPBF is if there is one part that I want to print and this part looks like this, so however you orient it, like in this manner or in this manner, support structure is needed. Here in this portion support structure is needed, and here in this portion the support structure is needed. So if now I want to deposit it in LPBF, this is my build plate. Now over my build plate, the powders are spread using a recoater. And now the laser is coming and melting the powders present over the bed. and the powders are then getting solidified. That melted portion is getting solidified. And now by this manner, when you are trying to deposit this part, so when you want to print this portion which is overhang, you have to have something below this so that that can act as a support structure from that portion to the build platform. Now here you can say, or one can say, the powder particles are present, so that powder particles can act as a support structure. What is the issue in it? The issue is there is a difference between a solid part and a powder part. So here the support is powder, and I am interested to build a support which is solid. Why? Because when the laser is coming from the above or top head, the laser will transfer the heat to the powders so that the powders can get melted and solidified. But if there is nothing, there is air below this portion, if there is air below this overhang portion, then the heat cannot be transferred and it cannot melt the powders which is present over that overhang portion, because here the support is made of powder. Support is powder, and powder is porous. There are air bubbles, air gaps inside the powders. Obviously powders are spherical particles. However, you, whatever way you want, you just compact the powder present in the build plate, there will be some air gaps still present inside the powder particles. And when the laser will come, the heat will just transfer to the build plate and it will just go inside the powders, and it will not melt the powders because there is air gap. In the air the heat is nothing, like what what air will do with the heat, it will just transfer. So I want to melt the powder present over here. For that I need to have some support which is solid. Only then the powders which is present over this solid support, if this is solid support, and here the powder is spread, then only the powder can get the heat from the laser and get melted. So this is why in LPBF or in any type of additive manufacturing process, it can be even SLS, the support structure is needed to dissipate the heat. And that's what I was trying to tell you, that the need of support structure is certainly the main point, which is overhang, to give a physical support to the overhang portions present in an object. And the second most important point is, even if there is overhang in the powders, still we need the support because we need to dissipate the heat. So heat dissipation. So heat dissipation is the second most important need of support structures. So whatever be the process, if it's powder bed fusion, if it's directed energy deposition, or if it's VAT photopolymerization, the support is needed. Now again, there is some other important point about support, which is like, after which of what will define the support, like what is a overhang portion, what is an overhang portion, how can I say that this is a overhang portion and this is not? So again, material to material it depends. For different type of materials, the need of support is different. For different processes, the need of support is different. Maybe, for example, for FDM, if this angle alpha is lesser than 30 degree and an overhang length L is more than or equal to 10 millimeter, then support is needed. Okay, so this is a condition for FDM. This is not true that for other additive manufacturing processes also this will be the condition. It may happen that for VAT photopolymerization, the angle alpha needs to be lesser than 15 degree, needs to be 50 degree, and if the length L is more than equal to 20 millimeter. Or if the alpha is less than 20 degree, for example, and the length is more than or equal to 20 millimeter, then only support is needed. So we can see in VAT photopolymerization the material is resin, and for FDN the material is polymer again, but thermoplastic polymer. So obviously this support structure, whether it is needed or not, this is a complete uh, thing which is dependent upon the material and the process. So from the STL file, we can see that after how much distance or after how much angle a particular tessellation triangle needs a support structure. So we know from the class that if this is a triangle and if this is having this normal, and if the triangle is having this normal, and if the triangle is having this normal, then for this thing the support is needed, and for this thing the supports are not needed. But this is not always similar or equal or constant to every additive manufacturing process, which is very important thing to remember always. So again, the type of support or the need of support is dependent upon the process by which you are printing, the material which you are printing. So it has been observed that for VAT photopolymerization or VAT photopolymerization, which uses resin as a raw material, uses it can print material uh, to some extent more without support structures. So if this is a part, maybe this process can print it without support, but if the process is, for example, FDM, it cannot print without support. But after certain angle, a VAT photopolymerization will also need the support structure. It is not true that it will never need the support. It will need the support, but it depends upon the material to material, because additive manufacturing process physics is all about how the material is interacting with the heat source, and it's all about how the material is getting deposited over the build plate. So every material has their own melting point, diffusivity, heat diffusion length, heat conductivity, shrinkage, solidification constant. So these all the things are different from material to material. So that's why their behavior under the heat interaction at the time of additive manufacturing is also different. So this is all about the need of support and the type of support. So it's not true that if somebody tells you that I have a part which is having an overhang portion, which overhang portion is having 10 millimeter length and an overhang portion and less than 30-degree angle, then whether it needs support or not. Question. So the answer will be we cannot say, we cannot determine, because it needs upon the process physics, like which type of AM process I am using and also which type of material I am using. The next thing which was studied was the different types of slicing, but before that, support minimization model, where multi-objective model was one thing. So it was something like, you just, there is one photo, so yeah, before this, if you're having the support, you just can optimize the support, like minimizing the contour. And another thing is, you can also minimize the support by orienting the part. Also, you can minimize the support by modulating or modifying the slicing. Slicing is again dealing with the solid body, unlike triangulation, because triangulation is done in the surface. So in slicing, we slice the object into layer thickness. Slicing is equal to layer thickness. So we can have direct slicing, we can have indirect slicing. So direct slicing comes with, just slice the parameter with equal layer thickness, which is T, and indirect is slice it with the from the STL file. Then again, we have uniform slicing, we have adaptive slicing, like if we have a very intrinsic feature in our part, or a very small feature size, like the part is in centimeter, but I am having one feature with some kind of hundreds of micrometer in dimension, and that feature needs to be printed with greater accuracy, then I will go for adaptive slicing, where the centimeter part I'll slice it with a particular layer thickness, and for the features which needs to be printed with better accuracy, I'll slice it with lesser layer thickness. That is adaptive slicing. The next thing is comes as conformal slicing, where the degree of freedoms are much more, because there the base plate can be rotated or translated or just tilted at some particular angle, so that the layer which is getting deposited each time is not flat, it's somewhat angular, just to have some material deposited at a part and some material not getting deposited at the same time, so that we can have different slicing, conformal slicing, to get better accuracy. Also, this conformal slicing can also minimize the use of support. So if my build plate is also rotating and tilting and translating, then you may make a whole sphere, even a hollow sphere, without a support using conformal slicing. But for that, a normal 3D printer cannot do it. So you have to have more degree of freedom in the printing process, in the printing attachments, like the build plate or the nozzle, which is depositing the material. Next is the indirect slicing technique. So there are bottom up, top down, negative tolerance, positive tolerance. I think you have seen these things in your lecture. So I have taken this photo, this screenshot basically from the lecture itself so that I can define it, how extra material is getting deposited in the top down approach in the upper part for this type of object, and in the bottom top approach, extra material is getting built in the lowermost portion. For negative tolerance, lesser amount of material is getting deposited, so after machining there will be lesser dimension than the actual dimension in the object. And again, the object dimension just can be exactly achieved by depositing it with positive tolerance, but again the material wastage will be more in this case. So these are some approaches but by which you can get different types of deposition pattern with indirect type of slicing. This knowledge can be used to minimize the support also. So then I have another screenshot, because in this small duration of time it was not possible for me to perform this whole thing. Like how you can just see that which support is external support or exterior support, which one is interior support, like which support is like the negative one, which is the positive one, where it is needed and where it is not needed. So this is very simple maths. I can You are able to do it, so I'm not showing it how to do it. The next thing is triangle sorting. So maybe I can show you here. Triangle sorting is like, if this is my triangle, this is my triangle, this is my triangle, and this is my triangle, these points are like, this all comes under indirect slicing, where we take the slice STL file where the whole object is made with the small triangles, and out of those triangles and using the coordinates of triangle, we just try to make the coordinates of sliced path, and then we slice the whole object. This is the idea. So here this point is over this line, so this is my slicing, this is T, and in these T, this points are coming, so this triangle will be considered. Now this triangle will be considered, and with this vertices and this intersecting point. This triangle will be considered with the intersecting points only. This triangle will be considered with these vertices, and this triangle will not be considered because there is no connection of this triangle with my interested line of slicing. So this was up to lecture 2. In lecture 3, the contours were organized in such a way that we can get the information, like which contour is having, like this diagram you can say, which contour is having this one negative thing and positive thing. We can say which one is exterior, which one is interior. So basically, if we are having one object like this, where there will be material and in which part there will be support, we can just see the ASCII format, and we can see this contour organization table, and we can say that here the material will be deposited, and here the support will be generated. So these are some simple techniques that we can see. Now again, most important thing is like, whatever we are doing here, we will not do it at the time of real model development. This is the basic knowledge that one should have if he or she is performing experiment in 3D printing, because this is the background work that is going inside the computer. We So you do not worry about this thing that you have to make this table and everything before 3D print some part. You'll 3D print it without doing these things, because you'll have much bigger object and you cannot make this 9 by 9 table for that. But if you are someone who is printing the part, who is doing work in additive manufacturing, then you should have the knowledge of the background work and background mathematics which is going on in the computer behind the STL file formation and the slicing. So up until this point, these topics were covered in the week 2 lectures. Again, the question that was raised in the class, that 13-14 question and one question related to the rotation and translation, I cannot solve it right now because I have seen the questions, but those were the questions of the assignment, and basically the quiz assignment, and I am supposed to give you the answers after the quiz is done. I think the quiz date is still remaining. The quiz is not done yet, so you can still attempt the quiz, and if I discuss the answer right now, then it will be not fair enough for the other students who have already attempted the quiz. So that's why for the quiz questions, I'll solve it in the next class. So this class will be used to basically discuss the topics covered in week 2 and the quiz questions already attempted for week 1. So I'll discuss the quiz 2 questions in my next doubt clearing session, so that will be fair enough for everyone. So right now what we can do is we can just solve the previous year assignment for week 1, as the previous year assignment for week 2 is similar like this year. So this is basically the week 1 question. So which one of following is or are not the popular term for reference of additive manufacturing? Okay. The answers are object manufacturing and the coating technology. Next is the as per occurrence in an AM process, put following operations in right order. One is generation of support structure. So the answer is, first we'll prepare the STL file. Second, we will save the STL file, and if needed, then we can manipulate the STL file. Then we will generate the support structure, and then at the end we will slice it. Next question is, based on level, form and accuracy, the detailed CAD model of a cricket bat is a dash type. Answer is complete, virtual and accurate. Next is, invention of computer affected the virtual prototyping and physical prototyping both. AM processes are inefficient for mass production right now, and it may be solved in future, but right now it's a problem for mass production because of the cost and the raw material cost. Then the objects with tailored material properties known as functionally graded materials. Next question is, as per ASTM, the AM processes are classified into 7 groups. Select the correct statement. So the correct one is, laser powder used in powder bed fusion is lesser than the power used in the directed energy deposition, because directed energy deposition, or DED, is the additive manufacturing process which uses the highest power of the heat source. Also, there is another answer, which is the laser powder bed fusion uses more power than obviously VAT photopolymerization. Again, VAT photopolymerization is a technique which uses the least amount of power in all other additive manufacturing techniques. Then the wireframe shown in figure A and B. So their geometry is same, but the topology is different, because geometry is defined by the length of L1, L2, which is same for both the cases, and R1, R2, the radius is again same for both the cases. But the topology is something how this is optimized and how this is looking. So by look wise, the topology is different. Then the STL format is a boundary representation method for representing the solid. STL is not known as, obviously, because STL was invented as stereolithography, but later on it is used for standard triangle language and standard tessellation language. After that, we have another question. Find the equation. So this is again a math. So if you have any query regarding this question, we can solve it. And the next question is again a simple one to make ASCII format, ASCII code. We can discuss it in class. The vertex in STL file can be shared by any number of triangles, and in edge by sharing by two most triangles. But again, if you are sharing a vertex by lot of triangles, then there will be error. There will be opening at that point, which is considered as a disadvantage fault of this one vertex usage of one vertex for multiple triangles. How many triangles will be required? So again, this is a math question, you have to solve it. Then how many triangles exactly to represent is none of the above, because 1 2 3 4 5 6 7, there are 7 uh, sorry, there are 5 walls. For 5 walls we can take 2 triangles, so 10 triangles, plus in the above it is pentagon, so minimum 3 triangle is needed to represent this uppermost pentagon. So 3 plus 3 is 6, so 16 is the correct answer. How many triangles will be required there? So it's 100. And that's about it. That's about today's session. Sorry for the in between interruption. There was a connection issue with the Gmeet, so I'll try to resolve it until next class. So until next class, if you have any other doubt, you can share it to me. Otherwise, you can mail me in this given email ID your questions regarding this week, as there was an interruption in this week's lecture, and you can raise your question in next class also. So thank you so much for attending this lecture. Good night. Take care. Bye.